I'll try not to. Yeah, I have a very short lesson today. I don't anticipate any difficulties. What I tried to do was look at your next assignment and keep my lecture as concise as I could. So I very deliberately handpicked 5 examples for the lecture to try to cover everything that you'll see in the assignment. That's always my goal is, does my lecture cover every possibility? So if Morgan's sitting at home doing her homework and she gets to number 16 and says, whoa, that's a little, she should be able to look back to her notes and say, oh, it's kind of like that one. And that's kind of always the goal. So I'll keep my lectures as short as I can. Kate, did you have a question, bud? Were you just stretching? Okay. Today is 8:30. Are there 31 days in August?
Yeah.
Okay, so we're not quite to September. We're almost there though. And wow. So 8:30, and what we are doing today and tomorrow is we are solving 2-step equations. So I'm trying to scaffold you up to the point where, say, like a week from now or so, where we start to blend them all together and you just don't even think too much about how many steps it's going to take. You just instinctively go in and say, okay, I got to do this and then this and then this and this. And so eventually, yeah, they become, I think 5 steps is probably the longest that you'll see. And when we get to ones with fractions, you might see 6 steps. But today is all 2. I promise that you can do all of today's equations in 2 steps. So that's going to be the goal. So here we go. And I did have to modify my note card. I realized my 5th example was easier than my first, so I'm calling an audible here. So this is your first one. So this time, I would always teach this lesson with the assumption that you've never done this, although I know that you probably have seen this before. You can't rely on just saying, oh, I have to do this, or, oh, I have to do this. We have to now strategize. There are 2 numbers that I have to kill, right? To get the M by himself, I have to kill that 8 and I have to kill that 64. And some people think about this as the reverse order of operations. I don't know if anyone's ever told you that before, but solving equations is really just basically doing the order of operations backwards. So in the order of operations, we would normally multiply before we add, right? We're going to go backwards and we're actually going to deal with the add before we deal with the times. I also alternatively think of it like this. I call this, and you don't have to draw this if you don't want to, but that is called something, you'll hear me say it a lot. That's called the variable term. I like to think of it simply as, I just got to get that by itself first. So, we're kind of saying the same thing no matter what words we choose, but that 8M has to be gotten alone. So step 1, you probably know where we're going with this, is to do what? 100% correct. We need to subtract 64 from both sides. And we are still in work show mode. We will be for several weeks here. So we're going to show the world that we're doing minus 64 on both sides. And my expectation is still to do those 3 housekeeping steps. And they are cancel, drop, drop. Those pieces should all fall into place before you actually do any math at all, right? So again, you've got the structure in place, and now you can worry about the basic math. What is 24 minus 64? Definitely negative 40. Good. We know that that's got to be negative because 24 doesn't have enough to take away 64. So, and now we're back to a yesterday problem, which is now a 1-step equation. And what do we do from here? We divide by 8 on both sides. And again, just get in the habit, do the 3 steps, cancel, drop, drop. And then you do the math. And what's a negative 40 divided by a positive 8? Good job. And as always, you're welcome / encouraged to check it. Go put it back in the original problem and say, does it 8 times that plus, let me see if it works. And if it does, when you're ready to hit full send, put a box around it and move on to the next one. That's okay. Any questions about that one? It's a pretty basic 2-stepper. Let's do another one that's kind of like that, but I'm going to trick it up just a little bit, but not a whole lot. So if I asked you to identify the variable term, what would you say it is? Good job. You guys aren't rookies. You're not saying 3x. It's negative 3x. So the isolation that we want to achieve is to leave all of this on its own. And how do we accomplish that? You got to add that 4. So you basically just want to get rid of the boring number first, the one that's not attached to the x. And so I'm going to add 4 here, and I'm going to add 4 here, and then I'm going to do my 3 steps. Cancel, drop, drop. And then you worry about the math. And what is negative 25 plus 4? Good job. Negative 21. Math is so much more fun when we don't have to stop and talk about negatives and positives. Good job. And then we divide by negative 3. And that is that. And we're done. We get x equals 7. And once we are sure that we love that, maybe checked it, feel good, full send, box it up. So those are really basic, just kind of normal looking two-steppers. The rest of these have a little bit of uniqueness, but not much. Are we good to go on to the last 3? All right. These questions pop up. I know they pop up in IXL a lot, and I do believe they also pop up on YTOP. So this type of equation, like this format, it's important that you know what to do. This goes against, not necessarily, but by appearance, it goes against what we just talked about. This is not going to feel like reverse order of operations. This one you kind of have to train into yourself. What does your gut tell you that we ought to do? Multiply by 3. Excellent work. I can tell you've done this before. The multiplication by 3 essentially makes that right side no longer have to be a fraction, and not being a fraction is a good thing. So, and I did have to lecture a few of you yesterday, stubbornly still using dots and X's. Remember, multiplication is always expressed with parentheses. So we're going to multiply both sides by 3. Now, the fun part about the right side is that the 3 doesn't actually ever multiply by the x and the 5. Why is that? Because it cancels. It never gets a chance. And so these 3's over here on the right-hand side just go, there's your cancel. And then we're going to drop the entire contents of the top of that fraction. We're going to drop the equal sign. And yes, of course, again, we have to do a little bit of kitty math. What's 3 times 6? Very good. And of course, now we would subtract 5 from both sides. What does x equal? 13. And again, give it a quick check, put it up in there. It works. Full send, box. Good. Still good? All right. Can I scroll up yet? Is everyone caught up? We good? All right. 2 more. This is an interesting one because there's a couple different strategies for this. And I'm going to show you this one can be a 2-step equation, but we can also make it a 3-step equation. And I know that today's lecture is about 2 steps, but I feel like I would be remiss if I didn't show you the other way, because the first way I'm going to show you won't always be a good idea. So you want to always have tools, like you want to use the right tool for the right job. And in this particular case, the most efficient route to get to the end of this problem is to divide both sides by -2. Can you think of a time when that would be a bad idea? Absolute poetry coming from that desk right there. Good job, Addie. If I had a number on the right side that didn't want to cooperate with my division, then I wouldn't probably take this route. And I'll show you the other way to do this in a second. And that would be the strategy that you'd very smartly want to use if that 16 were something else like a 15. Because as you know, 15 can't divide by -2, right? It comes out to a fraction. And you're like, why would I put a fraction someplace right away in a problem? Like, nobody wants to do that. So in this case, it was a great idea, and we're going to finish it off. We're going to cancel those -2's. We're going to drop our x minus 6, and we don't need parentheses anymore because the -2 is gone. He was the reason for them. If he's not there, we don't need them. And what is 16 divided by -2? -8. And as advertised, 2 steps, 1 down, 1 to go. What's our last step? Add 6 to both sides. Remember, always close off those addition and subtraction problems, seal them up, and then do your 3 steps, cancel, drop, drop. What's -8 plus 6? -2. Now I'm going to draw a big fat kind of a curtain here. And on the other side of this curtain, we are actually going to do the exact same problem again. And no, I'm not losing my mind. I want to show you the other strategy that, like Addie said, if 16 is not the kind of number that I want to divide, then this is my go-to strategy. So here we go. You could just distribute. If I distribute the -2, I do turn this into a 3-step equation, but I don't care. Like, we're all big kids, right? So if I take the -2 and I multiply it right there, what do I get? Beautiful, -2x. And if I multiply it right there, what do I get? Plus 12. Good basics. Excellent work. Remember, the -2 and the negative or minus, whatever you want to call it, they make a plus. And then the right side, I just copy down. That just equals 16. So again, this is a 3-step. You can see I did 1 step and created a 2-step. So math is easy. What do we do now? Subtract that 12 from both sides. So you want to go into, a good mathematician goes into a problem and says, like, I have a couple of tricks for this one. I'm going to pick the one that feels like the right trick. What do you mean by that? You cannot. Because this is not a -2. It's a -2 that's attached to the x, remember? And when things are attached by times, you can't add them away. You have to divide them away. And we're going to do that always in the last step. Okay. So my next line down is going to say -2x equals 4. And then the last step is dividing by -2. And of course, as you would suspect, we got the exact same answer again. X still equals -2. Like, the math gods don't care what way you do it. You're going to get to the same place if you don't do anything goofy. So that was the one that kind of worried me the most. So make good choices throughout the year when you see a problem like that. Division is always quicker if it works. The distribution is better when the division is going to suck. All right, last one, guys. And you're not going to struggle with this one at all. What should we do first? Adding 3 is the answer that we want. If you were thinking about multiplying by 4, you're not wrong. I would just tell you that that's not really the best course of action here. It's not very efficient, and you could mess it up too. So adding 3 is the perfect strategy. Let's do that. So I'm going to add 3 on both sides. Remember, everything we do, we are doing on each side of the equals, always. That's how this works. And then we're going to cancel out the -3 and the +3. And we're going to do, again, the drop before we worry about the math. Don't get all crazy and start worrying about the -7 plus 3. Drop down the extra junk, the x over 4 and the equals. And what? Give me just, can I have 15 more seconds before you go for your picture? And then I can finish. Huh? 8th grade. He's.
Jackson just forgot that he's a 9th grader now.
Oh, well, do I not have any 8th graders in first hour? Oh, that makes that easy. Anyhow, let's finish up. We dropped our x over 4. We dropped our equals. 7 plus 3 is probably the easiest thing I've asked you to do all day. That is 10. And there's our 1-step equation. What do we do to finish the job? Yeah, and remember, how are we going to do times? Parentheses. Those parentheses, as the equations get longer, the parentheses are going to go further and further apart because we're going to be putting parentheses around a big, long equation. So just get used to that. Anyways, times 4 on both sides. Cancel your 4s, drop your x, drop your equals. 4 times 10 is? And I hope so. And that concludes that. So same drill, your assignment is now, you'll see a space where the video is going to be, because well, duh, I'm recording it right now. But the assignment is already there, same drill, turn to the new page in your next page from where you did assignment 1, and let's get ripping on assignment 2. If you have questions, let me know.